Hey everybody, this is lesson 55 and it's Common Denominators Part 1. This is one of those really big ideas in 6th grade math. It's a pretty short and sweet lesson for today actually. I love lessons like this because it's just quick and to the point and it's just one particular skill we are practicing. But you should know this is a really big math idea in 6th grade math. So this is an important one, and I'm glad that you're watching this video. So common denominators, this is going to start to pull together a lot of the concepts we have been talking about up until this point, especially things that involve factors and like your greatest common factor or GCF. All of that work that we did was for a reason, and it was leading us up to this grand lesson today. This lesson is where we're going to put that into practice. When we're working with some equations today, you'll notice that as we're trying to find common denominators for two fractions in order to add or subtract them, the work that we do today will be kind of the very first baby steps in doing that. And in that, you'll notice that one of the fractions is fine as it is, and one of the other fraction will need to be renamed, is what they call it. It'll need to be fixed or renamed in order for both of them to have a common denominator. As we continue this work, so as you can tell, this will be to be continued. This is part 1. In part 2 of this work with common denominators, we will look at what do we do when both fractions that we're working with need a new denominator. And it's not that scary. You just basically do the exact same thing, but for both of them. So let's take a look at our learning targets. We have 3. Find the least common denominator of two fractions. Rename one fraction so that the two fractions have a common denominator. And then add or subtract two fractions that do not have common denominators by renaming one of the fractions. Because of course we know in our work with fractions or adding fractions, we cannot combine them, whether it be adding or subtracting, unless they have common denominators. That must happen first, and then we can do the work of combining them. This slide right here is just basically a pause to acknowledge what does it look like. What necessarily am I saying when I say common denominators? So common denominators, two or more fractions having the same number in the denominator or on the bottom. So this is the denominator place. We have 5 sixths, I said that funny, and 4 sixths. So they both have a common denominator. That's what we're talking about when we say that. Here's our very first example. I'm not actually going to ask you to pause the video for this unless you're feeling overly ambitious. Go ahead and do that right now. But this is our first example that we're walking through together. So I'm going to walk through this one nice and slow, and then we will have one more example for you to try on your own. We have here 3/4 plus 1/2. Right now, as it is on paper like this, we're not able to do this combining or do this work until we change this so that they both have a common denominator. So really, here's what we're going to do. We need to, I guess, literally and figuratively zoom in here on the denominators. We have a 4 and we have a 2. And here's where we need to start thinking about factors. What do these two numbers have in common? Or another question you could be asking yourself is, what is a number that both of these can go into? And I gave you a little bit of a heads up in telling you that one of them is going to be okay as is, and one of them is going to be renamed. In this case, and in every case when we're working with numbers like this, it'll always be the larger number of the two that can stay, and the smaller one is going to have to be renamed. And that's because 4 can go into 4, right? 4 divided by 4 is 1. So 4 can go into 4, and 2 can go into 4. But let's think about that backwards. 2 can go into 2, but can 4 go into 2? No. Or is 2 divisible by 4? Not perfectly. So we stick with the larger number to stay as is. 3/4 is going to stay like that. But in order to show common denominators, we need to literally rewrite this fraction right here so that it has a denominator of 4. And you can rewrite this any place you like. For some reason, I like to write it just right next door right here. I'm going to rewrite this fraction with a denominator of 4. I like things when they're right next to each other. It helps me keep things lined up. So if I do that, I need to think about a few things. Well, if my new numerator is going to be 4 right here, how did I get from 2 to 4? And I'm thinking in terms of multiplication. 2 times what will give me 4? Well, I know that 2 times 2 gives me 4. 2 times 2 is 4, and whatever I do on the bottom, I must do on the top in my numerator place. So if I take 2 times 2 on the bottom, I'm going to take 1 times 2 on top here in my numerator. 1 times 2 is 2. And you can literally just cross this off then once you're done. Cross this off. Because we're done with that old fraction. We're working with this new one right here. When we add or subtract fractions, our denominator stays the same. It carries right over. We've done all that work to come up with a common denominator. Luckily, it can just carry right over. And now we just add our numerators. We have 3 plus 2. 3 plus 2 is 5. And we come up with an answer or a sum of 5/4. Now, good mathematicians always stop and ask themselves, am I done? Is this answer reasonable? The answer is yes to both of those. You're done. The answer is reasonable, but there's a little bit of work we can do to make this answer in the best form possible. Right now, we're looking at an improper fraction. An improper fraction means the numerator is bigger than the denominator, and that's just not the best way to leave an answer ever. So we're going to turn that into a mixed number. That's what you do. If you're ever in a place where you end up with an improper fraction, the way that you reduce that or just put it in its the simplest form is to create a mixed number. That's just what you do. So we're asking ourselves, well, how many times can 4 go into 5? 1. So 4 times 1 is 4. 1 away from 5, we have 1 left over. Our denominator stays the same. Our final answer, after all of that combining, is 1 1/4. Okay, one more example. This one is for you to try on your own. 1/2 minus 1/6. So keep in mind some things that I mentioned in our first example. Please pause your video and give this a try on your own, and unpause when you're ready for me to walk through my answer. All right, so I didn't want to actually do too much work behind the scenes while the video was paused. I want to be able to talk through this work with you. When I'm looking at my two denominators here, I have a 2 and I have a 6. I know, because I gave you this heads up at the start of the lesson, one of these is going to stay and one of them needs to be renamed. So it's either going to be the 6 that stays or the 2 that stays. We have to think about a common factor that they have. 6 can go into 6 and 2 can go into 6. Okay, so that works. 2 can go into 2, but 6 cannot go down into 2. It's too big. 2 is not divisible by 6 evenly. So the number, I had mentioned this earlier too, it's typically the larger number, the larger of the two numbers that will stay. Not typically, it always is. The larger of the two numbers that will stay and the smaller of the two factors or numbers will need to be renamed. So the 1/6 is actually going to stay as it is. It doesn't need to be touched. But we need to do some work here to rewrite the fraction of 1/2 to have a denominator of 6. So I'm just going to start by rewriting the denominator of 6 just right next to my fraction right there. But I do need to ask myself, how do I get from 2 to 6? 2 times what will give me 6? And that's 3. 2 times 3 gives me 6. And whatever I do on the bottom in my denominator, I must do on the top to my numerator. So if I do the same thing up here, 1 times 3 is 3. And that's reasonable, right? 3/6 would be the same thing as 1/2. Yeah. Let's cross off that old fraction. We're working with two fractions here. We have 3/6 now minus 1/6. That denominator carries straight over. We've done all that work to get a common one. That can just carry right over. And we're just going to work with our numerators now. We have 3 minus 1. and we get 2/6. Okay. So again, a good mathematician will always stop and ask, am I done? Is my computation right? Is there anything further I can do to make my answer in the most perfect form? This answer is correct, but it can be reduced further. We can modify it a little bit. 2/6. We can reduce this. These numbers right here have a common factor. If ever in doing fraction work you can reduce, you must reduce. 2 and 6 have a common factor. Look at that. We were already working with those numbers. 2 and 6 have a common factor of 2. 2 is the greatest we can use because anything larger than 2 isn't going to be a factor of 2. 2 is the largest number we can use, but that's going to help us. That means we're going to divide our numerator and our denominator by 2, and it's going to give us a reduced fraction. It's important we do that if we can. 2 divided by 2 gives us 1 in our numerator. 6 divided by 2, 6 divided by 2 gives us 3. Anytime we have a 1 involved in our fraction in the numerator place, we're done. Our final answer is 1/3. So thanks so much for watching this really important